In this video, we're going to be talking about areas between curves. And if you're in Calculus 1, this might be a topic you're going to cover, but it's also a topic covered in Calculus 2. So this is kind of a Calculus 1 slash Calculus 2 video. So the idea of areas between curves, the procedure is exactly what the name is. You want to find the area between two curves. So let's look at this little sketch I've made, and it's, not drawn very well, but if I have a curve, f of x, this red line up here, and I have another curve, g of x, this lime green line, I want to find the area that's basically trapped between them in light blue right here. I want to find this area. And so the question becomes, well, how can I find that? What's the procedure to find it? And you're going to find out that it's actually really easy. And I'm just going to give you a quick proof as to why the formula is the way it is. So let's look at f of x right here. The area under f of x is basically in these red lines, right? It's the area all under this. Okay? So that's all of that part right here in basically dashed line red is the area under the f of x curve. Now, let's look at the area under the g of x curve. Well, if I do the same thing, I draw these lines, you're going to see they overlap at this little bit right here. But what's the area that I'm after? The area that I'm after is this in gray. I want this. I want this area right here. So this in gray is the area we want. The area trapped between f of x and g of x. So how would we find that? Well, look at this. This whole area right here, that was the integral of f from a to b. So that was the integral of f from a to b, so f of x dx. And then now what we're going to do is we want to, remember all of this is the area, and we want this area in gray right here. So let's subtract this area in green because we don't want that. We only want the area between this. So we would do minus this area in green right here. So the integral from a to b of g of x. And because these are two integrals and they both share the same upper and lower limits of integration, we can just combine these. We can just combine them. So this will become the integral from a to b of f of x minus g of x. And it's with respect to x. And that's really how you do it. It's not a really hard formula to memorize. Obviously, who is f of x and who is g of x is going to depend on what function you're dealing with. And for this reason, I'm going to call f of x, I'm going to say f of x is y top. So I'm going to call f of x y top. What this means is that it's the function that's above. This is the one that's always going to start. And g of x is the function that's below. It's y bottom or y bot. So, when you get like problems like these, it's going to give you two functions, and you basically have to graph them, and you have to decide, hey, who's y top, who's y bottom. Once you have that, then it's just a matter of solving a simple integral. So really just graphing these is half the battle. But in this video, I don't really want to waste time, graphing some of these because these are really just Algebra 2 topics. I'm going to be dealing with quadratics in here, and I have a video, one of my earlier videos that deals with quadratics and so on. And you might want to take a look at that. What I'm going to be using is I'm going to be using Desmos, and I'm basically just going to be copying and pasting the graph here to save time, and because it's a much better picture than I could ever draw. So before we get started on two examples, just remember this formula. It's just, it's the integral from a to b. Obviously, the limits of integration will sometimes be given to you. Sometimes you have to find them on your own, and we'll do that ourselves. And it's just f of x minus g of x, the integral of y top minus y bottom. So this is just going to be part one, and I'm going to be doing other examples, harder examples or more complicated ones in a separate video. So let's just start off with an example right here. So again, I'm going to clear the board. If you want to screenshot this, go ahead, but I'm going to clear the board right now. So clearing this. Okay. So let's say the function that we're given, let's say we want the area trapped between these two curves. Y is equal to 12 minus x squared. So these are the two curves we're given. Y equals 12 minus x squared and y equals x squared minus 6. Now, obviously, if you knew who was on top and who was on the bottom, then you don't really need to uh, you don't need to graph this, right? You could just do, okay, this function minus this function, right? The integral of that. But obviously it's not really apparent who's y top, who's y bottom. So this is when you would graph this. And I encourage you to look back in your Algebra 2 notes and review graphing quadratics, and that'll make this a lot easier. But for the sake of this video, I'm just going to be copying and pasting a graph from Desmos just to save time, because this video is really on, you know, finding the integral and calculating the area between these two curves, not so much graphing them. So okay, so here's the curve we're dealing with. And so I'll put it right over here. Okay, hopefully you guys can see that. Yeah, okay. Okay, so in blue, this is the blue graph, this graph right here. This is y equals x squared minus 6. So again, in the blue line is simply the curve y equals x squared minus 6. And the red curve is y equals 12 minus x squared. So y equals 12 minus x squared. And obviously, if this was your own homework or a test, you would draw this yourself. So okay, so let's ask ourselves, hey, what's the area we're after here? What's the area we want? Well, the area we want, it's the area between these two curves, and that area is this right here. It's all of this. And another thing I should have mentioned earlier is that it doesn't matter if your graph dips below the x-axis or not. It doesn't matter at all. It could be below the x-axis already or above it. Both curves could be, or one curve could be below it, one curve could be above. It doesn't really matter. So, here it doesn't matter that this is dipping slightly below the x-axis. So in gray, this is the area we want. Okay, so let's just compute what this area is. So if I look at this, I have to first ask myself, hey, what is y top? And what I do is I always write y top off to the side. So y top, well, y top is whatever function is on top between these two, uh, curves. So, what's on top here is the red curve, right? That's what's above in this area. So y top is 12 minus x squared. Okay, and then what about y bottom? Well, y bottom is the curve that's below, right? If I'm looking at this gray area, it's the curve that's on the bottom. So that's just simply y equals x squared minus 6. And I'll just put x squared minus 6. Okay, so, we've done half the work. Now we just have a little more to do. So, if I take this integral, obviously, I know who's y top and who's y bottom. I could just do 12 minus x squared minus x squared minus 6, because remember, it's just this y top is playing the role of f, and this y bottom is playing the role of g. So it's just y top minus y bottom, or f minus g. But you see here that I don't know what my limits of integration are. I don't know what the lower and upper bounds are. So I need to find that. So, sometimes when you're graphing this, you can see it pretty easily. Other times it's not so apparent because it might not be a nice number. A surefire way to find out where these graphs intersect, because I want these 2 points right here. I want this point in black and this one right here. So to find out where these two intersect, simply set them equal to each other. So if I do 12 minus x squared equals x squared minus 6, I can basically just solve for x and see, hey, what are the x values where these two graphs intersect. So I'm going to do exactly that. So I'm going to bring this x squared over. So I get a negative 2x squared. And I'm going to bring this 12 over. Okay, so I have a negative 2x squared. And then bringing this 12 over here. So let's do exactly that. So equals, so negative 18. Okay, and then basically all I have to do is I just have to divide both sides by -2. So I get x squared equals 9. And if you take the square root of both sides, you're going to get x is equal to plus or minus 3. Okay, so all I did was I brought this x squared over, brought that 12 over, subtracted 12, made a negative 18, divide both sides by -2. I got x squared equals 9. Square root of both, or yeah, took the square root of both sides. I got x equals plus or minus 3. So this part is -3 and this is +3. So now we have our limits of integration, right? And now we can basically just figure out this integral. So it's from, so this is from -3 to 3 of, so y top, which was, remember we said y top was 12 minus x squared. So 12 minus x squared minus, remember it's f minus g, or y top minus y bottom, minus, and be sure to put this in parentheses, x squared minus 6. And this is with respect to x. And your limits of integration, or whether it's respect to x or y, always depends on your limits of integration. If it's the limits are, x values, then, basically it's going to be with respect to x. But there are going to be other ones where we're going to be finding the area with respect to y, but not in this example or the next one. So okay, now we just have to solve this integral. So we get -3 to 3. If I simplify this, I get 12 minus x squared, distributing this negative, minus x squared plus 6. Okay. Okay, now we just have to combine like terms in those brackets right there. So I get, 12. So 12 plus 6, that's 18. Negative x squared, that's -2x squared. So -2x squared plus 18. And now I just solve this integral right here. So if I solve this integral, using the power rule, you basically add 1 to the exponent and then divide by that new exponent. It's -2/3 x cubed, and that 18 becomes an 18x, so plus 18x. And limits of integration stay the same. And so now we just have to plug in. So -2/3 3 cubed plus 18 times 3 minus, and I'll draw these brackets here, minus -2/3 times -3 cubed plus 18 times -3. And we really just have to solve this. So, if you plug this into your calculator, I'm going to do the first one. So -2/3 times 3 cubed plus 18 times 3. This is going to give me 36 right here. And then this next one, -2/3 times -3 cubed plus 18 times -3. So 36 minus, and this is a -36, 36 minus -36, that's going to give me 72. And that's my answer. So my answer is simply just 72. That's the area between these two curves. And 72 is a pretty big number, so that makes sense. This is a pretty big area. Okay, so let's do one more example, and this one shouldn't take us too much time. Really, this one took a long time because I was really introducing the procedure and everything. Okay, so let's do another example. So let's say I was given y equals x squared and y is equal to 2x minus x squared. So again, we're dealing with two parabolas again, and what I'm going to do is, again, I'm not going to waste time graphing this. I'm really just going to plug this into Desmos right now. And if that's a site you're interested in, I encourage you to check it out. It's just desmos.com. Okay, so let me copy and paste this graph right here. Sorry, I'm just doing it in another window, so you can't really see it right now. Okay, so I'm going to paste this. Okay, so hopefully you can see it. Okay, so in red, I have the graph y equals x squared. So the red curve is y equals x squared. And in blue, I have y equals 2x minus x squared. So really there's three things we have to do. We have to find out who's y top, who's y bottom, and the upper and lower limits of integration, and then we just solve a basic integral. So let's do exactly that. So let's first identify who y top is. So remember, we're after this area right here. This is the area between these two curves. We want, hey, what is this area? Well, if I'm looking at this area right here, well, the top curve and, from here to here, it's simply just the blue one. And the blue one is y equals 2x minus x squared. So it's 2x minus x squared. Y bottom is simply just the red one, which is y equals x squared. Sorry, x squared. And then all we have to do is just solve for our upper and lower limits of integration. You can obviously see this is just 0 and 1, but if you really want to make sure, then you can just set both of these equal to each other. So x squared equals 2x minus x squared. Basically, you would get 2x squared minus 2x equals 0. Factor out 2x, and then x minus 1 equals 0. And then you basically end up with x is equal to 0 and x is equal to 1. So basically you just set those equal to each other. You find out the x values, and those are your upper and lower limits of integration. So that's all there is to it. So 2x minus x squared. So again, x squared equals 2x minus x squared. All I did was I added x squared, and I brought this 2x to the other side, 2x minus x squared, factored out 2x. 2x times x minus 1, and I got x equals 0 and x equals 1. So those are my limits of integration. So this is 0, and then up over here is 1. So okay, so remember what the formula was. It's simply just, well, we're working with 0 to 1, and remember it's y top minus y bottom. So y top is 2x minus x squared. 2x minus x squared, y top, minus y bottom. And y bottom is simply just x squared, like we established earlier. And again, our limits of integration are from 0 to 1. Okay, and then now all I have to do is I simply just have to just evaluate this integral. So I get 2x minus 2x squared, and I just have to solve this. So 2x minus 2x squared, well, this is going to become, x squared minus 2/3 x cubed, and the limits of integration stay the same. So, I would do 1 squared minus 2/3 times 1 cubed minus 0 squared minus 2/3 times 0 cubed. So this is just 1 minus 2/3 minus 0 minus 0. And this becomes 1 minus 2/3, which is just 1/3. And that's my answer. My area is just 1/3. And that makes sense because this is just a tiny area. Obviously, this graph is zoomed in a lot. And again, you would get this graph by graphing it yourself. I just used Desmos to save time. So hopefully this makes sense. Again, these can be a little more complicated, especially if it gets evaluated into or divided into two integrals. And I'll make 2 more videos, one where we're dealing with x top and x bottom, and another one where I deal with a case where it breaks up and we have to evaluate 2 integrals. But I'll do that in future videos. So again, hope this helped. If you have any other questions or want me to cover any more topics, feel free to message me. And sorry that it's been a while since I uploaded a video. I've been taking a little break, and since summer started, there's not really a high demand for videos right now since, obviously school's not in session. So hopefully this helped, and feel free to message me if you have any other topics you want me to cover. And as always, thanks for watching.